Now we're going to look at combining our synthetic division with the possible rational zero theorem to find all of our zeros, given that we start with none. So easiest way is just to do an example. This is really combining two of the videos together. And you'll see it stated something like this. Find all zeros of, we'll call it f of x is equal to x cubed plus 2x squared minus 5x minus 6. So notice the difference between this problem and one from several videos ago. I said find all the zeros of this function given that 3 is a 0, or whatever number it was. Here I'm just telling you find the zeros. So if you get a problem like this tells you that first we need to figure out what the possible rational zeros are. So we have to start by finding the PRZ, possible rational zeros. On the top, it's the factors of the constant term, which is -6 or 6, however you want to view it. So you can draw a tree of everything that would multiply to give you 6, and you'll get plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And then the bottom is the factors of the leading coefficient. Here's my degree, its coefficient is 1. So the only factors of that is 1. So this one is a little bit simpler. So you can go ahead and you can write it out if you still need to. So you can say plus or minus 1 divided by plus or minus 1, comma, plus or minus 2 divided by plus or minus 1. You can write it out like I did in the previous video. Here I'm just going to do a little shorthand, but because there's only one number on the bottom, and so it's easier if you have multiple numbers on the bottom to write everything out. That way you don't miss something. But since there's only one, this one's pretty easy. You can just say 1 divided by 1 is plus or minus 1. 2 divided by 2 is 2, so plus or minus 2. 3 divided by 1 is 3. And then 6 divided by 1 is 6. So those are our 8 potential zeros for this function. Now what do we do? Answer that question yourself. Pause the video if you think you know how to do it. I'm going to continue. So we need to, let's just randomly pick one of these 8 possible rational zeros, and let's see if it happens to be a 0. So we start by drawing our box, and we start synthetic division. So let's pick 1, positive 1, and let's see what happens. So the numbers we list here are the coefficients, so I get 1, 1, 2, negative 5, negative 6. 1, 2, negative 5, and negative 6. You go ahead and work through this whole problem and just this synthetic division and see what you get. So you start by bringing down the 1. 1 times 1 is 1, and we always add down. 3. 3 times 1 is 3, and we always add down. That gives me negative 2. Something didn't work out here. What didn't work out? I'm not going to get a 0 here because negative 2 times 1 is negative 2. If you add that down, that gives you negative 8. Now, is that a 0 to this function? No, it is not. This is not a 0. This means, since we did not get 0 in the remainder, this means 1 is not a 0. All right, so this is where trial and error comes into play. You're just going to have to keep trying until you find one. And once you find one, though, once you find a 0, then we've got a foothold on this function. Once we find that 0, then we can, just like in previous examples, then we can start doing some factoring on our numbers down here. So let's try another one. If you need to practice, pause the video. Let's try 2 this time. And then the coefficients are the same. Bring down the 1. 1 times 2 is 2. Add down, gives you 4. 4 times 2 is 8. Add down, gives you 3. 3 times 2 is 6. Add down, and that gives you 0, which is what we are looking for. When we have 0 in the remainder, that tells us that this number is a 0 to our function f here. That's an x-intercept. All right, so now we could go through the other 6 using synthetic division, and then we could just find all the zeros that way. But let's not do that, and that's not going to be how that's not how I'm going to ask you to do it on the test. If you give me 8 of these graphs and you find all zeros and you tell me that's the answer, that's going to be wrong. What you need to do is just find one 0, and then we need to work this out. So start on the far right. This is your remainder, r, which is 0. That's what we're looking for. This is your constant, your x, and your x squared. And so these are my coefficients to each of these terms. So this gives me 1x squared, so x squared plus 4x plus 3. And so what does that look like? That looks like something we can handle, that we're used to. This is a quadratic. Quadratic we can do the AC method on. And then out will pop our other 2 zeros by just doing the AC method on that quadratic there. So imagine if you did your PRZ and you had 1,000,000 possible rational zeros. You wouldn't go through every single synthetic division just to find the zeros. So, but nowadays, in a real world example, if you had 1,000,000 zeros, you could program Excel or something to go through and find all these. But for what we're doing, this is the easiest and fastest way. So we're going to take this now, and it's supposed to be set equal to 0. So x squared plus 4x plus 3 is equal to 0. So we're going to use AC method here. And if you're still struggling, please get help. X plus 3 times x plus 1 is equal to 0. And so now we can separate these set them separately equal to 0. So on the left we get x is equal to -3, and over here we get x is equal to -1. Alright, so you got my answers. But if you would have said this is my answer, that would have been counted partially wrong. I will give partial credit, but you need to write in your answer that this also was a 0. So comma x equals 2. So x equals -3, 2, and -1 are your zeros here.